Hi, I'm Desai. This is the presentation of our work, GAIT, Generating Aesthetic Indoor Tours with Deep Reinforcement Learning. Given a 3D indoor scene and a neural network that evaluates aesthetics of an image, how can one generate aesthetically pleasing view sequences? We introduce GAIT, which is a framework to use deep reinforcement learning to generate aesthetic, smooth view sequences in 3D indoor scenes. This view sequence and the video are produced by our deep reinforcement learning agent after 3.5 hours of training. In this task, manual work could take hours. Numerical optimization methods are inefficient in the high-dimensional continuous output space. Through expensive experiments, we show that our deep reinforcement learning agent can control the camera to generate aesthetic, smooth, and diverse view sequences while satisfying initial pose, excluding pose, and boundary constraints. We formulate the aesthetic view sequence generation task as the following. The agent observes the camera pose, the camera view image, observations for smoothness and diversity, and time step. Its action space is the change in camera pose. Its reward function includes the aesthetic score and the smoothness and diversity scaling factors. The aesthetic score of a camera view image is computed by an aesthetic model that matches human aesthetics. The smoothness ratio penalizes abrupt actions and zero actions. The diversity ratio penalizes if the camera enters excluding regions. With our framework, we adopt two visual deep reinforcement learning algorithms that uses image augmentation as additional training signal to achieve better sample efficiency. DRQV2 uses random shift augmentation as a task invariance perturbation to regularize the Q function. Curl uses the random crop augmentation for contrastive learning. We use the same network architecture for DRQV2 and Curl's actor and critic networks. The image observation first passes through a CNN encoder. Then it is concatenated with the rest of the observations. The actor's output is the action, which is a 5D actor. The critic additionally takes action as the input and outputs a scalar representing the Q value of observation and action. This is the overview of a GAIT DRL agent in the multi-GPU training setting. In the data loop, the actor interacts with the environment repeatedly and saves each transition in the replay buffer. The update worker samples a batch of transitions from the replay buffer and updates the actor and critic networks based on the loss functions of DRQV2 and curl. We can see that the GAIT, DRQV2, and curl agents outperforms CMAES and MPC on the average sum of rewards over 3 scenes. In the user study, GAIT DRQV2 is significantly favored versus CMAES in all categories. GAIT curl and GAIT DRQV2 each has their strengths and weaknesses, but is similarly voted overall. In the ablation study, we show that the linearly decayed exploration noise and the image augmentation are critical for DRQV2 and curl. In addition, our framework paired with either DRQV2 or curl has a robust training curve with respect to different random seeds. When the diversity regularization is disabled, the agent robustly moves from different initial camera poses to the same high aesthetic score region. When we enable the diversity regularization, the agent can generate diverse trajectories from the same initial pose. It can also provide user with additional control at the inference time. Here, the two trajectories has the same starting pose, one trained with the temporal smoothness regularization and one without. As a result, the second trajectory contains abrupt actions and stays at the same pose in the end, which is suboptimal and trivial. You can visit our website for more qualitative results. Thank you.